Happy New Year, everyone. This is Chuck Schultz again with Michigan Sawmill Sales and Patriot Builders. We're here today to talk about the anatomy of a Michigan pole barn home and what we do for insulation. So I believe we have a very cost-effective pound for pound insulation package with a Michigan pole barn home. One thing we always do, we're going to start with the floor. We always, no matter what, whether we're doing hydronic floor heat in the home or not, we will use a 2-inch rigid foam insulation board all the way across the living space of the home. And our garages are always finished and insulated just like the homes typically. And so in that case, we will always put a 4-foot border around the outside edge of the garage envelope, the unconditioned space of the home, usually the garage or shop. So that way if they wanted to add heat later, it's already prepped for it. And that's usually done to a minimum code specification. It usually would require that on a slab on grade here in Michigan. But on the living space, we always do a rigid foam insulation underneath the entire living space of the concrete floor, which usually always is the finished floor unless somebody wants to put floor covering products on it. And then the garage floor will always have a cold joint from the garage floor to the house floor, and usually that is also to help bridging that colder temperate floor from bridging its temperatures into the living space where it borders the garage. Then we move along to our walls. Our walls, if you look at the last video we did of our exterior wall sections, explaining how the header connection happens and the wall girts and everything and the interior framing, if you notice on that, the interior wall studs and the exterior wall girts, there's a 2-inch gap in there, and that creates a break in the thermal bridging. And in today's standards, it's kind of a big deal to have that thermal break because it does equate to higher performance and lower energy bills dramatically. And that wall section will automatically, by default, that wall section it's got a thermal break in it. So that's a very, very good thing. And then what we do is we use open cell, which probably is a different topic for another video. We use open cell because we have to have in our code here in Michigan a home wrap on the house, which is usually a vapor barrier home wrap. And you kind of don't want to have develop a double vapor barrier situation in a home. It's not you don't want to develop that. I've had inspectors and other people ask me, why not closed cell? It's better, it's got more R value per inch. Yes, in a lot of cases the closed cell is better performing wise, but not much. I know it may have another 2.5 R value or so to it per inch, but it's not so much the R value that makes an energy envelope operate efficiently. Another big thing is air passage. I've read somewhere years ago that the biggest energy loss in a home is air leaking. So if you can create an air barrier, which you can do, it's open cell. I believe you got to have more than 3 inches or 4 inches or more of open cell to create an air barrier, which it doesn't matter what R value you have in your walls. If you have air leakage passing through that wall when the atmospheric temperatures outside are different from the house, they're never equal. You lose a lot of energy that way, more so than the R value of the insulation itself can protect you. So by default we get an air barrier out of that because we're putting 7 inches of open cell spray foam in that wall, and now we're able to fill the whole cavity. You wouldn't want to fill the whole cavity in closed cell You lose a lot of redundancy if you have to run another electrical wire or do a little bit of a change or whatever. It makes things very, very difficult with closed cell in that aspect. And then the cost of closed cell, a lot of people will do a 2-inch and then bat insulate the rest, or a loose fill, or a different type of less expensive insulation to gain that R value, which is a good system. They call that the flash and bat system. But in our case, we still have that vapor barrier on the outside of the wall that's per code. And I don't want to get into arguing or trying to get an engineer involved to tell the municipality that we don't need to follow the code for home wrap. It's best off for us to just go to the alternative, and I think the benefits outweigh going with closed cell. The benefits of going with open cell, I think, far outweigh the benefits of going with closed cell in this situation. So we get that 7 inches of closed cell. It's argued, I'm not a licensed expert in chemistry of closed cell and open cell and all the different densities that you can create with it. I know the lowest density you can get with closed cell is roughly around 3.5. You can get up to going up to the medium or more heavy densities of open cell. You can get up to 5 per inch. That's up to your contractor and your insulation contractor and the product that they use. There's many different products that the contractors can purchase and use for insulating your home for different performances. I want to say, I'm going to correct a video from the past. I think I put on there R35. Just a disclaimer, we may not have the heaviest density of open cell at some cases, so going with a medium, you're probably at a R value of around 4, 3.8, somewhere in there, which would take us to anywhere from 26 to 28 R value with just open cell from that outside wall plane to the inside wall plane. I think I typed on that video that it was an R35. Is it possible for us to get an R35? Yes. Yes, we can do that. But on the standard, we're going to assume that R value is going to be somewhere between R26 and R28, which is still rather high. And then considering the fact that we got an air barrier in that wall, and considering the fact that we have a thermal disconnect. So that 2-inch airspace performs that break into thermal bridging, which is kind of the Achilles heel in platform framing. So before I keep rambling on, let me show you the diagram real quick. I know I showed these diagrams on the last video, but if you haven't watched it, go back to it, but this will quickly kind of show you kind of how we take care of the exterior wall before we move on to the attic insulation. So I'm going to flip this around. All right, so hopefully everybody can see. This is the diagram of the header connection. That's a face view and a side view, so you can see how the header's connected to the column. This is a double line right here representing the outside wall plane and the outside of the column, and then where it hits the wall girts, here and so on, going down. And this is the line representing the inside wall plane or the inside of the column. Okay, so we get a total of, from this outside wall plane to the inside wall plane on our standard, 7 inches of spray foam in there. We fill that entire void. Then on this outside line here, there's going to be a home wrap and then the siding. Typically a sheet steel siding. If you had vinyl siding or horizontal siding, you'd probably end up having to put exterior wall sheathing on the outside of the walls before you did that, so it would make it a little thicker. So let me roll this overlay down. So if you can see this here, let me get the air out of it. So that's as if the trusses were set and we frame the inside wall. So that kind of shows you as the insulation comes in here, it is going to take up that insulation is going all in here. Okay. So we're getting that. We've got this 2-inch air barrier here, which is giving us our therma disconnect from all our wall girts and anything touching the exterior wall to the inside. So we're getting a very good performing R value out of that. And then when you move up to the header area, now you get a little constricted in here because this is solid mass, but again, we're insulating full in here. So you end up with a little bit less insulation right up in here. And then the spray foam goes up onto the heel, and then they have a baffle, an air baffle up on the bottom side of the roof deck. And then it goes up high enough to where they can blow in. So this is where we get into the insulation in the attic. After the drywall is on the attic, they go, they blow in 16 to 18 inches deep of cellulose, which equates to about 4850 R value up in the attic space. And then we do a lot of pressurization stuff like sealing all the duct penetrations through the interior walls, exterior walls, light, anytime we can seal up a light penetration, electrical penetrations, plumbing penetrations, when vent stacks going through there, we'll foam around all those so we can get a good air barrier between that outside envelope and the inside insulated envelope. And that also helps us with our pressurization, when we do our blower door test at the end of the day. And usually we pass those with flying colors. And usually it's because of the precautions our insulators take up in the attic space with sealing every little nook and cranny up there before they blow the attic space. So that is the standard of a Michigan pole barn home insulation package. Can we do it cheaper? Yeah, I highly advise not. I try to get my clients to always understand if we have to worry about budget, that is one area we do not want to cut corners on. Because ultimately, if you're saving a few $1,000 on your insulation, it's ultimately going to cost you that much year over year, every single year for the life of the home. So that's kind of not putting money in a place that really makes sense. It's just bad practice in my opinion. Now, one thing that is really interesting to me is that over the last year or two, I've learned of this term called a passive home design. Now, our Michigan pole barn homes aren't typically designed to be a passive home. And when I kind of was like, what is this? I really was struggling with another term for another home, like this was some hoity-toity design feature or something. Like, what is a passive home? And they're pushing the green initiative, all this stuff, and lower carbon footprint. And when I got to really studying it, I learned that it came from Europe and Germany, and it's a great practice, don't get me wrong. But it does, on a typical form of construction, say a platform home, over a crawl or a basement, it's going to increase the cost of that home by about 15% of the construction cost is going to go up by, you basically add about 15%, sometimes as low as 10, but I don't know if I buy that number, and especially in today's world. The nice thing is some of the benefits of doing passive home design is ultra high efficient insulation packages that you can attain. And by default, we attain a lot of those theories with the Michigan pole barn home on our standard insulation package, and just by default on how we frame the exterior. So I think we're getting a lot of beneficial gain just on the design of a Michigan pole barn home by default. And it's just over the years, I've been in the business, I've been in construction for 26 years. I've seen a lot of things, and some things has just been out of experience, I don't know how many broken bones I've had, how many ounces of blood have been spilled or whatever on the job sites from day to day to day over the years. Not so much anymore, I'm usually in the office, but, but we've got a lot of experience of doing things and learning from the past. And our pole barn homes today have innovated from when we first started doing them. Oh boy, 6, 7 years ago maybe, when our first one for hire. And we've innovated everything. Every time we do one, we find something to improve on the next one and everything. And we've refined our process over the years, and this is what we have today. And the nice thing about, if you're really concerned with that passive home design, low energy footprint, this is already a high performance home as far as energy is concerned. Like, this is really, it's even shocked me at the performance of these homes. If you wanted to, I'm going to shoot this camera over here on this plan. So even if you research what a passive home is, and I apologize for my camera here, but you can even create a deeper wall cavity by pushing this 2x4 stud wall for the interior frame in another 3.5 inches, and now you've got a 10.5 inch thick wall, and now we can really start chasing that passive home design feature. You know, if you really wanted to go for the passive home design rating, it's expensive, and again, the functional gain out of the expense is something that has to be worthwhile to you. It's always worthwhile to me, but you know, sometimes we got to find that matrix of where energy efficiency, material, you know, the passive home design and regular homes, platform framed homes, chews up a tremendous amount of materials. It's not just the insulation you're worried about. I mean, when you're building double walls, think about how many more trees that have to get cut down, or how much more lumber that has to get purchased. The labor involved with doing that. By default, our Michigan pole barn home does make that simple if you wanted to chase that passive home design. I'm really passionate about these builds. I hope you guys are getting something out of this video as far as understanding our insulation, our standard insulation package of a Michigan pole barn home by Patriot Builders, and intrigues you and makes you look into whether or not you have a contractor in your area that's building one for you. Show this to them. Maybe they got some more things to add on to it. Maybe there's some better benefits that they have in their experience, you know. This isn't the be-all, end-all, but I think this is a good pound for pound, dollar for functional gain system. I'm going to touch on, you know, my favorite test subject, which is my brother. I built his house a few years ago, and his house, it's on YouTube. It's the Standard Ranch. I've got a series on my channel for the Standard Ranch style post frame home. That house is about 1,530 square foot on the living space. It's a 3-bedroom, 2-bathroom ranch. Nice little open kitchen, living room design. It's got a 600 square foot garage. They have a furnace in the garage to keep the garage conditioned. The heating source and cooling source is a forced air furnace in the house. They also have their range and cooktop connected to gas, and they're on propane. They burned from, I believe it was April of 22. They had their tank topped off, and then the next time they had their propane tank topped off was March of 2023 this year, and their consumption was 230 gallons of propane. We are in northern Livingston County, southeast Michigan, so we did have somewhat of a temperate winter last winter, kind of like how this one's going. It wasn't very cold, but that typical house, if it was platform framed to the average norm of construction around here, insulation, everything, 2x6 exterior walls, all that stuff on a foundation, that average home should potentially consume on propane, how his home is equipped, should consume roughly 8 to 1,200 gallons of propane per year. And they consumed 230 in like 11 or 11 and a half months. So call it 250 gallons of propane for a fiscal year. If it's a hard winter, he probably will push the 300-gallon envelope. But at the end of the day, his isn't the only study case that I follow. They've all followed extreme energy savings from the norm of construction. Normal insulation packages, the standards. So it really does pay to let us put these kinds of bones in the house with the insulation package. And that is basically the standard insulation envelope of a Michigan pole barn home. Hopefully that explains anything. If you have any questions, drop them in the comments below. Subscribe to the channel. I really appreciate you guys watching. All of our subscribers, thank you for subscribing. Happy New Year. This is New Year's Eve, and I'm gonna get wrapped up here and try to enjoy the New Year's Eve. Be safe. Happy New Year.